Here we go. This is roughly a summary of everything. The only thing that's not on here is quadratic trig equations and period changes, I think. But let's walk through this. The tides at White Rock Beach reached a high today of 4.5 meters at 6 a.m. You know what? I'm going to do a little sketch. So the high was 4.5, and that occurred at 6 a.m. This afternoon, they will be at their lowest. So the lowest is at 2.3, and it's at 12:15 p.m. Now, I will not go 12.15 because 15 minutes is not 0.15 of an hour. What decimal portion of an hour is 15 minutes? Well, what fraction of an hour is 15 minutes? Quarter, so what would a quarter be as a decimal? Okay. So I'm at the highest right there, I'm at the lowest right there. You know what? They've given me half of a trig function, half of a trig wave. Okay. Oh, I'm always interested in the middle. What's halfway between 4.5 and 2.3? Well, sometimes you can just see it, but the easy way to do it if you can't see it is to add them up and divide by 2. There's my vertical displacement. Oh, and now I know my amplitude. How high up and how far down am I going? Can you see it? It's like 1.1 and 1.1. Might be negative, might be positive. I don't know yet. I'm going to decide what kind of a trig function I'm going to use in a second. Period. Half a wave is 6.25 long. How long is the whole wave then? I think 12.5. B is going to be 2 pi over 12.5. And you know what? I'll just leave it like that. I could decimalize it. If you did, I wouldn't take marks off, Cassandra. Well, why bother? If I start up here, which trig function starts up high? Negative sign, negative cos, or positive cos? Okay, so I'm going to do this as a positive cos with a phase shift of t minus 6 to the right. That's one possible equation. If you got that, the way I mark these for 2 marks, half mark for the amplitude, half mark for the period, half mark for the phase shift, half mark for the vertical displacement. Did anybody do negative cos? No one did? Okay. Anybody do a sine graph because it said sinusoidal and you went, oh, sinusoidal means I have to do sine, even though I've said it doesn't have. Okay. So if you got this right, great. If you did not, half mark if you got that right, half mark if you got that right, half mark if you got that right, half mark if you got that right. Now let's go to my graphing calculator because part B wants me to do something with this. I better make sure I'm in radians. Hey, I am. Clear whatever I have here. 1.1 cos 2 pi bracket x minus 6. Oh, well, let me do a closed bracket on my keyboard. Nice try. Divided by 12.5. Okay, that's how I would type that. An open bracket starts my trig function at the beginning automatically. That's the way my calculator works. I add whatever brackets I need to for the phase shift, and then I close the trig function off. So the mistake a lot of you are doing is you're putting your closed bracket right there last time. Plus 3.4. Now this is a bad question in some ways. You're going to see why in a second. Window. 0 to 24 would probably be good. 24 hours, going up by 4. Why min? Now normally I like to see the ground. But for some reason, this particular tide... Oh, no, wait a minute. What's the vertical displacement? What's the amplitude? Sorry, I thought this one went into the ground. That's a different question on one of my other quizzes. For some reason, the tide goes below sea level, which I guess could happen if you had a valley or something. Anyways, well, I want to see the ground. The highest this gets is 3.4 plus 1.1. You know what? I'm going to go to 5. If you went to 6, that's fine. 2. Scale, I can go up by 1s, I think. Let's see. Tide goes up. Tide goes down. Tide goes up. Tide goes down. Now, if I really, really wanted to be fussy, Ryan, I might consider doing a period of that big. Sorry, a window of that big, because that would be exactly 2 whole waves. 12.5 times 2. But I'm good with 24 hours. We're fine. 3:30 p.m. Is that an X value or a Y value that they gave me? It's an X value, so I'm going to let X equal 3.5. Oh, no. 3:30 p.m. How will I type 3:30 p.m.? I'm going to type an X value of 15.5. I'm going to type an X value using the trace button of 15.5. What does it say to 1 decimal place? 3.4 meters high. Is that right? No one nodding? Is that right? Yes? H of 15.5 equals 3.4. Now, if you did trace 3.5 because you missed the PM and you got 3.7, I'll give you a half mark. I think on... never mind, I'll take that back. I was going to give you a hint, but I might be wrong on the hint. What's the first time today that the depth of water was 4 meters? Hey, that's a Y value. Y equals 4. Graph. First time today is right there. Second function, calculate. Intersection. First curve. Second curve. Guess. Is that the first one that I want? Then I'll show you a quick shortcut. My guess is going to be 1. That way it's faster than doing all the arrow keys. I just pick a value that I know is far up on the far left of the graph. 4.1 decimal place. T equals 4.02 hours. I'll take that because I didn't say to go to hours and minutes. But if you then went 0.0227 times 60, apparently 401 if you made it a time. 4.0 I'd take as well, because I did say to go to 1 decimal place in the first question. Any questions there? Cool. Prove each identity. Once again, I'm going to show you one possible way to do these. If you did it a different way, talk to me after and I'll give you a yay or a nay. Hopefully you all got the right-hand side correct. Suggestions for the left-hand side? Got to try something. I'm not leaving this blank. No freezing up. What would I try on the left-hand side, Amanda? Yeah. Let's try rewriting everything. Sorry, 1 plus sine x equals cos. It does not. No. 1 plus sine does not equal cos. Sine squared minus 1 equals cos squared. There's nothing I can do here. Folks, there's only one thing I can do here. What am I going to do here? I got to rewrite it in terms of sine and cosine. And since that's going to give me a fraction on the bottom, I'm going to be really clever and make everything a fraction on the top as well. That's what I have to do. Now, as soon as I do that, Trevor, my job has been started for me. Trevor, is this a complex fraction? Say yes. Then, is there more than one fraction on the top and the bottom? So I can't just go, how do I divide by fractions? Look at the multiply. I'm going to have to use this trick that Mr. Dueck showed me, which was multiply the top and the bottom, Amanda, by a common denominator, which is going to be okay. Now, ready for an advanced move, Andrew? Will anything cancel on the top when I multiply this out? Will anything cancel there? Will anything cancel there? Then it's worth your while to leave it factored, because I guarantee you if you multiply it out on the next line, you'll pull out a GCF. I'm actually going to leave the top as 1 plus sine x sine x. They're all over 1. Can I get rid of the over 1s now? Yes. On the bottom, here nothing will cancel. I'll have a sine x Here, a sine will cancel. I'll have a +1. Do you see now why I left the top factored? Can I cancel? Is the top factored? Ah! That's one way of doing it. How would I give out part marks on that one? Hello, Trig Quiz 6 answers. Come on. Don't freeze on me. Here we go. Let's make the screen bigger. Let's go to 200. And that should get the identity all on one page. Oh, I didn't do part marks. I would go something like this. If you rewrote it, what's this? What are these out of? 4 marks each? I would give you 1 mark if you rewrote it in terms of sine and cosine. I would give you 1 mark if I saw you do that. I would give you 1 mark if you got to this line and 1 mark for the canceling. Probably something like that. Now, if you did it a different way, show me after. B. This was fairly tough. Both sides are ugly. I'm going to spend Katie more time on the left side, but I'm going to do as much as I can on the right side and then quit. Because on the right side, I think I'm going to go like this. 2 times 1 over sine x times cos x over sine x. I would rewrite the right side as sine and cos. And when I do that, Stephanie, on the top, I'll get 2 cos x, and on the bottom, I'll get sine squared, and I'm pretty much stuck there. Okay. On the left, any thoughts? Andrew is correct. He says common denominator. Now, a reason I think that, Sabrina, is, Sabrina, how many fractions do I have now on the right-hand side, grand total? 1. How many do I have on the left-hand side? Let's try writing them as 1. Now, to add fractions is the most difficult fraction operation. I need a common denominator. Sabrina, what do I have on the bottom of the first fraction? Read it out to me. What's the bottom on the second fraction? You know what my common denominator is? 1 minus cos, 1 plus cos. The same way as if I had a 4 there and a 5 there, my common denominator would be 4 times 5. 20! My common denominator is going to be 1 minus cos, 1 plus cos. To do that, I would multiply this one by 1 plus cos. This looks sort of like we're doing the conjugate, but we're actually finding a common denominator. It's just that the common denominator itself happens to be a conjugate. And I would get this. 1 plus cos x times cos x, and then a plus sign would drop down. I might be tempted, Shannon, to multiply that out. You know what? I make so many dumb mistakes on these, I'm not taking any shortcuts. Here, I would multiply by 1 minus cos x, 1 minus cos x, and I'll get cos x 1 minus cos x. Is that okay so far, Holly? Let's do the bottom first because it's a little less yucky. If I FOIL this out, if I go chunk, 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 I think I get 1 minus cos squared. And Steph, right about here was where I got my nerdy adrenaline rush, because you know what 1 minus cos squared is also the same as? Sine squared. I went, apparently the bottom is going to work out. I'm guessing the top will too. Let's be careful with our algebra. It's going to be cos times 1, which is cos x. Cos times cos, which is cos squared x, plus cos x minus cos squared x. Oh, not cos x squared, Mr. Dueck. Cos squared x. Oh, I said, look at this. It's a look. Yes, because cos squared minus cos squared, it cancels. And I have cos x plus cos x on the top. What's another way to write 1 cos x plus 1 cos x? And you can figure that out also by glancing at the right-hand side and saying, oh, goody, 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 goody. That's one possible way of doing it. Did I do part marks here? Nope, but I bet you I did it the same way. Yep. I would probably give you 1 mark if I saw that and got to there. You know what? Half mark for doing that, half mark for getting to there. So 1 mark if you got to there. I would probably give you a half mark if I saw you do that step. Where would you lose marks? I would be very fussy. Andrew, if you just wrote this, I would take a half mark off because you've multiplied by something that isn't a 1. That's such a bad sloppy habit. I need to beat it out of you. You're actually multiplying the bottom as well and not showing me that step. I would say, nuh-uh. So I would need to see that. I would need to see that. Then I would probably give you 1 mark for that, 1 mark for that, 1 mark for that. There's my 4, probably. But if you got something similar, you get 4 out of 4. Let's go up to C. Okay, Dueck. I got exactly 2 trig functions. Do I want to leave this as, well, I don't know whether I want to rewrite this as sine or cos or leave it as is. You know what's going to decide it? I don't have my sheet in front of me. You guys do, I hope. Is cosecant squared minus 1 something on your sheet? It can't be cotangent. Oh, is it cotangent squared? And it is cosecant squared. So cotangent squared plus 1 is cosecant squared. You know what? I'm going to do that substitution because anytime I can go from 2 terms to 1 term, it makes the algebra way easier. So I'm going to replace this with first. I think I would do that. Now, Ryan, I'm going to rewrite everything in terms of sine and cos. This is going to be cos squared over sine squared. This is going to be 1 over sine squared. Holy smokes, this is just going to fall apart. Because the right-hand side now, when I multiply it out, I get Is there anybody that rewrote everything in terms of sine and cos right away and didn't notice that you can do that substitution, which makes your life way easier? I'll do it the other way if you want me to. None of you did? Maybe I did on my answer key, can't remember. Nope, I caught it there. That's probably the easiest way to do it. If you had rewritten this all in terms of sine and cos, you would have then found a common denominator here. You would have written it as 1 fraction. I think you probably would have had to factor out a GCF to get something to cancel, and then you would have been good to go. Last one. This is a sum and difference identity. I'm going to just move the negative cos x way over here because I'm pretty sure I'm not going to use it anymore. Negative cos x. This is the sign of alpha minus beta, where alpha is 3 pi by 2 and beta is x. I do not have the sign alpha minus beta memorized. Steph, you got it in front of you there? Can you read me the sign of alpha minus beta? But instead of alpha, can you say 3 pi by 2? And instead of beta, can you say x and read slowly enough for me to write? Go ahead. This 3 pi by 2 is interesting. 3 pi by 2 is right there. Right? What's the sign right there? Behold the human unit circle one more time. If my arm is 1 long so that r is 1, and my arm is 1 long and sine is y over r, it would be negative 1 over 1. Oh. This is a negative 1, and I'll drop the cos x down. And I like that because that matches over there. Let's drop the minus sign down. Hey, what's the cosine of 3 pi by 2? Well, that would be x over r. Behold the human unit circle. My arm is 1 long. Oh, Katie, what's my x coordinate? If I'm on the y-axis, how far left, right have I moved? 0. Oh, what's my x coordinate then? 0. What's the cosine of 3 pi by 2? So this whole thing is 0 times sine x, and Katie, in your head, no calculator, what's 0 times anything? Oh, you mean it just vanishes like that? And I do get... I would probably give you 1 mark if I saw that, 1 mark if I saw that. Yeah, actually, I'm going to take that back. A half mark if I saw that, a half mark if I saw that, 1 mark for that, 1 mark for that, that's up to 3, and then 1 mark for that, there's 4 marks. You mean we wouldn't get anything for writing the right-hand side? No. Give it a rest. Multiple choice. 1.5 marks each. Is this always true? Is it true when cosine is not equal to 0? Okay, first of all, can cosine be equal to 0, or will I end up dividing by a 0? If cosine worked out to 0, would I end up dividing by a 0? That's a restriction. I think this is going to be wrong. Always true, never true, none of these. I'm kind of suggesting none of these is also wrong. Let's find out. Oh, let's see if I can rewrite this side as that, maybe. I don't know. Sine x tan x is going to be sine x times the sine x over cos x plus 1 over cos x. I can write that as sine squared x over cos x plus 1 over cos x. Okay, algebraically, that and that are equivalent, because that's going to be sine squared x plus 1 all over cos x when I do a common denominator. You know what? It's true when cos is not 0. Number 4 is sneaky because I'm asking you a period question, which is totally fair game, but I'm throwing tangent, which we haven't done for a while. The period of tangent wasn't 2 pi over b, it was pi over b. Ugly cousin. So it's going to be pi over 2/3. Right? How do I divide by fraction? Flip and multiply. It's going to be 3 pi by 2. Oh, it is none of these. Sheesh. I don't give multiple choice tests with none of these. My friend who made up this test does. I don't do all of the above, none of the above, some of the above. I don't do that. Because, as it turns out, number 5, the answer is also none of these. Why is the answer not 2? Yeah, tangent doesn't have an amplitude. It shoots up and down to infinity. Looks like John Travolta doing a little disco move, right? Number 6. Shannon, what does number 6 want me to find? Oh, the alarm bell should go off. You know why? It's not factored. Is there a coefficient in front of the x? Say yes. Okay. So right now we have this. A 2 on top of the x and a 4 on the bottom of the x. I'm really saying I need to factor out that 2 over 4. That would leave me with an x and a minus. Minus what? Well, when we're factoring, we're dividing. It's really going to be 5 divided by 2 over 4. Steph's moving her lips trying to figure it out. Or she's just listening to voices that none of us are hearing. Be afraid. How do I divide by fraction, Steph? So you're saying this is 5 times 4 over 2, which is 20 over 2. You know what? Also none of these. Really? Are there 3 none of these in a row? That's a weird quiz. None of these, none of these. Oh, hang on, Mr. Dueck. What did I do here? I did that one wrong. Let me take that back. Sloppy math, Mr. Dueck. The 4 is factored out. Let's try this again. I need to factor out the 2. There's already a 4 on the bottom, but I need to factor out the 2 from the top here. When I factor out the 2 from the top, it's going to be x minus 5 over 2. Yeah, the answer is C. I'm sorry. I like number 7. I like number 7. I like number 7. Number 7 is a nice question. fact, it's probably going to be one of the first questions on the multiple choice section of your test. I'm going to ask you to find the secant or the cosecant or the cotangent. Radians or degrees, number 7. Is this radians or degrees, and how do you know? Is it radians or degrees, and how do you know? Now, I got Nicole. You know how I got Nicole? Because I put 45 there, and you like 45. Or I could have put a 90 there. Is there a degrees symbol next to the angle? Is there a little degrees symbol right there? Then it's always radians. They loved to do that on the provincial exam. They would give you, find the secant of 180, but not degrees. And all the kids would switch their calculators back to degrees, because 180 is such a nice angle in degrees. This is radians. So I'm going to make sure I'm in radians, which I think I am. Then the next question is, how do I find secant? Ashley, what does secant go with? Sine, cosine, or tangent? It's one over cos, which is technically now on your formula sheet, but that's one worth having here, I think, Ashley. So I'm going to go 1 divided by the cosine of 45, 1.9. The most common mistake, Cassandra, kids go like this. 1 divided by the cosine, and for some reason they think they have to flip the angle. They want 1 over 40. No, we're not flipping the angle. We're flipping the cosine, which means, in fact, if you want an even quicker way to do it, it's this. Cos 45, close bracket. Here's the reciprocal button, the little x to the -1. That takes the reciprocal of whatever answer you started with. That's also a nice quick way to do it. C. How many solutions will this equation have between 0 and 2 pi? 6. Oh, normally it has 2. Period change, 2 pi by 3. There's going to be 3 waves instead of 1 wave. Instead of 1 wave between 0 and 2 pi, so instead of having 1 sine wave with 2 solutions, we're going to have 1, 2, 3 sine waves with 6 solutions. How many solutions will this have? Well, there's a 3 there. I need to do a bit of algebra here, I think. Let's see. Let's do number 9 right here. If I get the sine by itself, I would minus the 5 from both sides. Yes, Andrew? And divide by 4. What's the amplitude right here? Because how big is that? Negative 1.25. It's never going to get that low. This graph will never cross that graph. None of these. And number 10. The graph, blah, 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 will have maximum y values in the y direction of... Well, let's see. The first thing I see is the sine graph, which looks like this. But then they took the absolute value. So the absolute value would look like that. And then, what does a +1 do? Move this graph how? I can't hear you. Up by 1. So instead of being at 1, it's going to be at 2, and it would be, oh, the highest value it's going to have is 2. Lowest value it's going to have is 1. A little bit of sneaky review. These are 1.5 each. Give yourself a score out of 32. But 32 is too big a quiz. Then divide your score by 2. And then I thought this quiz had too many tricky questions, so I'm actually going to make this quiz out of 15. Yes, you can get more than perfect. You can get 16 out of 15 if you're really, really good. Give yourself a score. Last day. Last day, I didn't do a lesson per se. I will once again start out by saying, hey, from the homework from lesson 10, were there any that you wanted me to go over? Yeah. Sure. The only problem with that, so I was asked, how do I decide my view window? I mean, the object is you want to be able to see the whole graph on your screen in at least one wave worth. So for your x value, usually you're going to say, how long is the period? I'll go from 0 to the period. Unless you notice in the question, they're asking an x value further on than the period. So there was one question in the homework, I think, where the period was like 30 seconds, but they were asking something 45 seconds. So I went to 60 seconds, 2 periods. Okay. For the y value, 0 preferably, and then unless it goes below 0, then I'll move lower down. And then I look at the vertical displacement plus the amplitude, and I add a bit more so that I'm centered in the screen. That's really rough. Any others just about the homework? Okay. I prepared this morning. I don't have it pre-photocopied. You want to know what's going to be on your test? You might want to write this down. This will cover about 90%. It won't cover a couple of the curveballs, but some of those are on the review. So your trig test is on Monday. April 23rd. I think I sent out an email yesterday, did I not? And I think I had my 2 trig video tutorials from the last couple of years in there, as well as a link if you want more reviews. What's going to be on the written section? Here's the first question. The first question is going to be solving a trig equation with a period change. Something like 5 sine 2x equals -4. Between 0 and 2 pi. Why did I write give answers to 3 decimal places just now? Do I have a triangle with a 5 and a -4 in it, or a 4? Okay, so we're going to find the reference angle with decimals. First of all, Nathaniel, can you recognize that this is a period change question? What makes this a period change question? The coefficient. The fact that there's something in front of the x. Let's get the sign by itself first of all. How would I get the sign by itself? Really? Yeah, I got it up, right? Divide by 5. First thing I would do before I did anything else is I would say, okay, this is going to be and then I would say I'm going to replace the x with an a because I don't like the period change, so I'll get rid of it. Oh. And I'm going to make a note. The new period is, I don't want to forget that there is a period change, so I always write that down while it's fresh in my mind. So we are going to solve this. All right, now what? Now what? How would I solve this? Which is going to be about 1/3 of your test in less than 1 week. People, come on. Can't get the a by itself. It's stuck inside the sign. What? How will I find the reference? Even before that, what have I done every time I've been solving a trig equation? Very first thing. We've done it about 100 times so far. Cassandra! What? Darn right! First thing I'm bringing out is the cast rule and sketch, yes? And by the way, if you really didn't know that, you're in trouble. Expect to see you here Friday after school. Oh, what will I do now? Where will I put a couple of little angle marks? What quadrants? And don't give me the letters, give me the numbers. Quadrant 2, I agree with. No, not quadrant 2. Sign is negative. That tells me where it's positive. 3 and 4. Okay. Because now I've narrowed it down to half the circle. Now I need to find the reference angle. We have two methods. If we know a triangle with a 4 and a 5 in it, we would sketch the triangle. Do we know a triangle with a 4 and a 5 in it? Okay, then we're going to find the reference angle via calculator. It's going to be the inverse sine of, am I going to type negative 4 over 5? No, I already used the negative to find where I am. It's going to be the inverse sine of that. Give it to me to 4 decimal places. Since they want the answers to 3 decimal places, I'll carry an extra digit so that I don't round off too much. You get a reference angle of 0.9273? 0.9273, yes? Which means that angle is 0.9273 and that angle is 0.9273. What's my first A value? How can I figure it out? Pi plus, can you do that on your calculator? Can you go pi plus 0.9273? What do you get? By the way, up until now, I think every period change I did as an exact value question, which is also still fair game, but just for kicks, I'm doing one with decimal answers. Okay. 4.069. Now, that's the first A value. What's the second A value, Nicole? 2 pi minus, which is, sorry, what? Yeah. What do you get? I should make a little note here. This is pi plus 0.9273, 2 pi minus 0.9273. Sorry, Nicole, what? Now here's the problem. I found A. There is no A in my original question. What letter was in my original question, Andrew? Well, what letter? X. Okay, based on this little statement right here, if you know A, how would you get the X by itself? Divide by 2. So X1 is going to be A1 divided by 2. It's going to be 4.069 divided by 2, which is what? I know it's going to be 2 point something. 2.0344? I guess since they only want 3 decimal places, I could quit there without the extra 4. What would X2 be? It would be the second A value divided by 2. Oh, by the way, if these were exact values, dividing by 2 was the same as Amanda just putting an extra 2 in the denominator, right? Or if there'd been a 3 there, dividing by 3 would have been the same as putting an extra 3 in the denominator. So we did it for exact values. Now we're doing it for decimals, which in some ways is easy. It's more mechanical, Tyson. We're using our calculator. Tyson, what is 5.356 divided by 2? 2.688. Round it off properly. Okay. No, I said to 3 decimal places, I think, in the original question. Okay. Are there more? Is that bigger than 2 pi? What is, by the way, as a decimal, roughly, what's 2 pi? 6.28? It's kind of, now that's my cutoff, right? If I get bigger than 6.28, I'm going to quit. Okay, maybe there's an x3. How will I find that? Take the 2.034 and add the period, which was pi. Okay, 2.034 plus pi, 5.176. Is that bigger than 2 pi, Nathaniel? No. Maybe there's an x4. Let's see. That's going to be 2.688 plus the period of pi. 5.830. Is that bigger than 2 pi? Not yet. Is there a fifth angle? Well, if I add 3.14159 to that, in my head, I already know I'm in the 8s. I'm bigger than 2 pi. So here are my 4 answers. B says, give the general solution. Okay. My first x, my second x, plus multiples of the period, where n is an integer. That will generate all of them. Shannon, am I wrong? Or Nicole, am I wrong? No? Oh, okay. Okay. Ready for curveball number 1? Curveball number 1. Says, nope, that didn't work. Leave it. The 2 smallest positive solutions of the cosine of 4x equals 0.6 are 0.23 and 1.34. Determine the general solution. I ripped this from an old provincial. This is meant to be really, 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 really easy. But for some reason, kids find this really, really tough because the wording is strange. Carson, read it out to me again. Stop. Didn't they actually just give me those? That's what this is saying. By the way, when you solve this, your x1 and your x2 were that. What does it want me to find? Won't the general solution then be x1 equals 0.23, x2 equals 1.34, plus what? What's the period of this graph? Which is what they're trying to test in this strangely worded question. Which Amanda has pointed out is pi over 2. Yeah, that's all they wanted for this question. How many marks is this question worth, Katie? 1. A whole bunch of kids completely solved this, like we did up above here, taking 8 lines, taking 15 minutes, found those answers, which they already got, and then did that. That's not what they were testing. They'd already tested, could you solve one of these? They wanted to know now, could you do the general solution? Trig word problem. Going to Katie's question. So the second question on your test is going to be on the written. It's going to be some kind of a trig word problem. Listen closely. Tides, Ferris wheel, or some other application. There is another type of a trig word problem on the multiple choice tides or some other application, but heck, I'll just say it. The written one's going to be a Ferris wheel. Because how can I resist that? I'm using a park ride. It's going to be very similar to this one. A Ferris wheel has a radius of 24 meters. Passengers get on at the lowest point, which is 3 meters above the ground. Takes the wheel 35 seconds to go around once. Write a sinusoidal equation. Does that mean it has to be sine? No, it means it can be your choice. Sorry I didn't get a chance to get this photocopied. This is what I was typing like mad when people were walking in this morning. All right, let's see if we have a bit more success here. What am I going to do first here? Yeah, I'll do my sketch over here so I have lots of room to write the equation nice and big. And specifically, what am I interested in here, Carson? Highest, lowest, which gets me middle. Sometimes they give you middle. Okay. What's the highest these people get on this here Ferris wheel? Or what's the lowest? In fact, I think the easiest one to find is the lowest. What's the lowest? Doink. In fact, I think the next easiest one to find actually is not the highest, it's the middle. What's the middle going to be? 27, because of the radius. Doink. What's the highest going to be? 27 and 24, 51? Which of these three numbers is going to show up in my equation? The 51, the 27, or the 3? Height as a function of time. What's my amplitude? Sorry? 24? Okay. Let's decide whether we're going to go positive sine, positive cos, or negative cos. This is why I said I want 1 point. They got to tell me where we are somewhere. Where have they told me that we are at a certain time? I'll give you a hint. It's the second sentence. Oh, passengers get on. That would be time 0 on the, you know what? There's my point. Oh, Carson, which equation would be the wise one to use? Positive sine, positive cos, or negative cos? Which one starts at the bottom, like this one? I think negative cos. Because if I go negative cos, Andrew, you know what my phase shift is? Nothing. All I need to get is b, which is going to be 2 pi over the period. What's the period? There. Oh, by the way, I guess that means after 35 seconds, we're back at the bottom. Could you find when we're at the top? Yeah, it'd be half of 35. It would be 17.5. That's when we're at the top. Could you find when we're in the middle? Yeah, it'd be half of 17.5, which I think would be 8.75. I'd have to divide by 2. Could I find when I was there? I could find, if you wanted me, Amanda, to do a positive sign or a negative sign or a positive cos. I could, and what the phase shift is. But since I didn't say you had to, oh, for Pete's sakes, let's use a phase shift of 0 and negative cos. Katie, let's go to type this in. I'm going to freeze the screen because a bunch of you had problems last day typing this in. Try typing this equation in from scratch. and I deliberately haven't showed you how I typed it in because that's what you need to practice, I've gone to the window right away. Katie, you think you got it typed in okay? Okay, I'm going to pick on you because you asked this question. Let's see if you and I can derive the window. Looks like X is measuring time, yes? Almost always we like to start time at 0. What would I like my maximum time to be? How about once around? Unless they asked me a question, unless I scanned later on and they were asking a question about 50 seconds or something, then I'd go 2 periods. But for now, yeah, 35. Good scale. I don't know, how about 5s maybe? Wyman, I like to see the ground. Katie, what am I going to put for my Y max? How high did your graph get? So 51, that's the height my graph got, which would be right on the top of the screen. And you may have noticed stuff gets chopped off a tiny bit by the screen. So I always pick, give me a nice number a little bit bigger than 51. That's how I pick the windows. Katie, what would be a good scale to pick if we're going from 0 to 55? Go up by what along hash marks? 1s would be bad because it's going to be, I won't be able to tell them apart. Yeah. There's no right answer for window. There is some wrong answers. If you went from a height of 0 to 40, I'd say, well, you chopped off part of the graph. That's dumb. Or if you went from an x value of 0 to 10, I'd say, why wouldn't you graph one whole wave? That's dumb. Okay? Hit graph and see if you get this. And if you don't, one last time, now is your chance to raise your hand and I'll come see how you typed. Actually, you know what I'll do? I'll let you see if you can figure it out yourself. I'm not mentioning any names. And folks, the fact that this many of you are having trouble typing in the equations suggests lesson 9, where they gave you the equation, might be worth redoing, or for some of you doing for the first time. Because that's where you practice actually typing these in from typewritten equations to what they look like on my calculator. Are we happy now? Yes? Woohoo! All right. Nicole, what's the first time that the riders will be 12.5 meters above the ground? All of you, find this. I'm not going to tell you how. Do it. You've done the hard part. You already got the equation typed in, right? Okay. Steph, what'd you get? 41.9. Anybody else? Tyson's so enthralled he can't get his knees. Send a line 12.5 across high. That's y2, right? And find where they cross. Because they gave you a y value. If they gave you an x value, use the trace button, which I didn't bother giving you in this one for some reason. Okay, so it's going to be a word problem. Then you're going to turn the page. You're going to say, oh, Mr. Dueck has 2 identities. I have one medium and one medium plus. I have a couple of simple ones on the multiple choice. I have one nasty one on the multiple choice. But your identities, medium, medium plus. I yanked these from provincial exams. I don't know how tough they are. I just yanked them this morning from the last 2 provincial exams that were released. The fact that there's a secant cubed makes me go, but that's okay. Yo. 5.13? Okay, so when I said, is that the correct answer, and everybody said yes, and I'm deliberately not doing this because you guys sponge off me way too much. Let's try this again. Thank you, Amanda, for having the integrity to perhaps challenge this. What is the correct answer to this one here? Let's see. So I think you went trace 12.5, which is incorrect because this is not an x value. Meters, Steph, that's a y value, is it not? So if it's a y value, I have to go like this. I don't know why I put it in y3, but I guess I did. That's fine. Second function calculate intersection, first curve, second curve. Yes. I don't want that one. I would have guessed of 1. I think 5.14, because I round off properly. That I agree with. Thank you for pointing that out, though. And can we all follow along? And if you think they're wrong, feel free to tell me. It's a group democracy, and I'm trying, with you guys in particular, not to show you what I'm doing. You need to wean yourself from just copying what I do. Okay. Here's an identity. Sine theta over 1 minus sine theta plus sine theta over 1 plus sine theta equals this. Now, I'm trying to plan my attack. Holly, how many terms do I have over here? 1. I have a feeling I'll common denominator this eventually. In fact, this is very similar to one that we did earlier today with the 1 minus sign and the 1 plus sign. I think I'll end up with a 1 minus sine squared in the bottom. I think I'll end up with a cos squared in the bottom. I'm kind of trying to plan my attack. I don't know quite how it's going to go. I'm going to tackle the right side first because I have a feeling I'm going to do a little bit and then quit. Sine 2 theta. That's an identity. What is the sine of 2 theta? No, it's not 1 minus. What's the sine of 2 theta? This is right from your sheet. Sine of 2 theta, 2 sine theta, cos theta, yes? Right? Oh, and then what's secant? 1 over what, Carson? So what's secant cubed? And then I would say, because this is technically over 1, I can multiply. Trevor, how many coses on top? How many on the bottom? 3. How many left and where? How many on top? How many on the bottom? How many left and where? How many left and where? 2 on the bottom. The cos is going to cancel. Okay? In fact, I get this. Oh, actually, I think this is exactly the same one as we had on our... No, I think we had a 2 cos theta on the top over here and a sine square. It's almost identical, though, isn't it? I bet you it's going to be the same strategy. We're going to find a common denominator. What's my common denominator going to be here? 1 minus sine theta, 1 plus sine theta. How would I turn a 1 minus sine theta into a 1 minus sine theta, 1 plus sine theta? I'd multiply the top and bottom here by 1 plus sine over 1 plus sine, which would give me 1 plus sine times sine. I multiply the bottom here by 1 minus sine. 1 minus sine. The plus sign would drop down. I'd get a sine theta. 1 minus sine. So far, so good, Nicole? Now what? When I FOIL the bottom out, what's that work out to? 1 minus sine times 1 plus sine. Which on my next line is going to be... Yay! I don't know if I have my nerdy adrenaline rush yet, but I'm pretty close. Oh, and then I'm going to go multiply, 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 multiply. I'll get sine theta plus sine squared plus sine theta minus sine squared. Itzel, can I do that? Yeah, that's not canceling. That's something minus itself is always 0. I don't have to worry about is it factored or not because I'm not canceling up and down on denominators. And I have a sine plus a sine, which I'm pretty sure last I checked was a... Yo. Yep, hustle back. Hey. Let's try this one. Prove this. Tan x bracket cos x plus cotangent x all over secant x plus tan x equals sine x sine 2x all over 2 minus 2 cos squared. Alright, so what am I going to try first? Freaking out? Okay, I freaked. Now what? I think with all these different trig functions, rewriting everything in terms of sine and cos, and I think I'm going to start on the right side because it's a little less ugly, and then I'll spend most of my time on the left. So in your hints, I said start on the uglier side. Really what I should say is to spend the most time on the uglier side. Because this is a sine x, I can just rewrite that. Oh, and Carson, what's the sine of 2x the same as? Right from my formula sheet. All over. Does anybody see something that they should do on the bottom? There is something that suggests itself to me. I think it's worth factoring. Why? I think it's a GCF. You get a 1 minus cos squared, right? Pull a 2 out of a 2, you get a 1, then a minus sine cos squared. Katie, on the top, I have sine 2, sine cos. I got sine sine. Holly, what's a nicer way to write sine sine? Okay, I think the top is, I'll put the 2 in front where we're used to seeing it. A sine squared x and a cos x. And the bottom, I have a 2. Oh! It's 1 minus cos squared. Oh. Can I cancel? Did I factor on this line up here? Can I cancel? Is it factored? Yeah. Can I cancel? Is it factored? In fact, I think now the 2's will cancel. The sine squareds will cancel. Tyson, you know what the right-hand side works out to? I have to admit, that's kind of nice. Which means, I guess the left-hand side is going to end up being that. This big monstrosity apparently is going to end up being that too. Ooh, I like this one. What did you say we should try as our strategy? Okay, let's rewrite everything here in terms of, do I want to FOIL first and then change? You know what? I'm going to multiply everything out first, then I'll rewrite everything in terms of sine and cos, because it's probably easier to do that after I've got rid of brackets, okay? So I'm going to go tan x cos x plus tan x cotangent x all over secant x plus tan x. Can I cancel a tangent out? Nope, because I haven't factored. All right. Roxanne, tangent is what over what in terms of sine and cos? Someone hasn't done much of the homework. Can you keep your identity sheet right in front of you? That would be really handy, I think. Yeah? Your formula sheet? Because I'm going to keep coming back at you now. And then it's times cos x over 1 plus, what, Roxanne, what did you tell me tangent was? And that's going to be times, what's cotangent then? Cos x over sine x all over secant is 1 over cos, tangent is sine x over cos x. This is a complex fraction, but let's just, before I start doing that trick, I think I can do some simplifying. Okay. What weird stuff. Okay. What's going on here, Mr. Dueck? That doesn't want to move around. Move you down. Okay, we'll come back to that, I guess. I got wonky formatting happening here. Oh. This little mini fraction has a cos on top and a cos on the bottom. I think this little mini fraction simplifies to sine x. Yes? Right? And then Shannon, a plus sign drops down. This little mini fraction here, the sine would cancel top and bottom. Cos would cancel. Oh, you know what tan x times cotangent x actually is? 1, not 0, 1, right? Because we're dividing. All over. Do I have a common denominator here? Yeah. Do I want to write it as a common denominator? Yeah? Okay, let's try it.
Mr. Dueck, I thought you said if you have one fraction, you'd like everything to be
Fractions. I did. Here's what I do notice, though. How many fractions do I have on the bottom? 1? How do I divide by one fraction? Amanda. So are you saying that this is the same as that? Ryan, is that true? Can I cancel? Oh, is it factored? By the way, what am I trying to get? What do I have sitting right there? Think I can cancel those out? Ha ha. Okay, a couple of identities. Okay, now you guys seem to have fixed yourselves. Let's do this. Insert space. Cut. Paste. Okay, now you seem to be wanting to work. Okay. It's about 5 minutes left. I'm going to temporarily pause there. Now, give me a second here. Click. Bear with me for a couple more seconds. So I gave this out last day. This is your homework. Friday, I'll take questions from here. Friday, I'll give you a few more hints. Friday, we will also probably start lesson 1 of the next unit, which is Nerdly Cool, and a fairly short lesson. Okay? So I emailed this out as well. This is what I gave out last day. This does have the answers attached to the identities if you look. I don't know if necessarily that the author has used my particular method of solving some of these, but you find, if this thing actually loads, that for the identities they've actually shown all their steps. Okay, I'm done talking. Lots of talking.